Hello and welcome to the program Sula's Big Adventures with me, Sula. This episode is about nebula filters for your telescope. Before I get started, let me apologize for my gruesome appearance. I was trying to put my Lasmandi mount into the garage and the tripod leg got hung up on the lip and it fell back and it fell on top of me, smashing my face. So sorry for looking like I have on an early Halloween costume. Before I get started with nebula filters, let me tell you what a nebula is. A nebula is a giant cloud of interstellar gas and dust, often spanning several hundred light years in size. The gas is mostly hydrogen and helium, and it's not very dense, only 1 atom per cubic centimeter. But with enough gravitational attraction between these giant clouds of gas and dust, matter can clump together, becoming more and more dense and bigger until it gets so big that the clump collapses from its own gravity, causing material at the center of the cloud to heat up and cause fusion, and this hot core is the beginning of a star. Many nebulae are formed from the remnants of dying stars and are supernova remnants. Massive stars explode in a supernova, and smaller stars like our sun eject their outer layers of gas into space over tens of thousands of years, leaving behind hot core, a white dwarf. Radiation from the white dwarf causes the gas to glow, creating beautiful formations called planetary nebulae. In nebulae, which are star-forming areas, ultraviolet radiation ionizes the surrounding hydrogen gas, causing it to become visible at optical wavelengths. There are 5 categories of nebulae. Diffuse nebulae have no defined boundaries, and within this category are emission nebulae, in which the hydrogen and other gases are energized by the ultraviolet light from a nearby star. These are usually red because the emission line of hydrogen is red. Another kind of diffuse nebula is the reflection nebula that reflects light from a nearby star. They do not respond to nebula filters. Dark nebulae are clouds of gas and dust so dense that they block the light behind them. Probably the most famous dark nebula is the Horsehead Nebula in Orion. Then there are planetary nebulae like the Helix Nebula, the closest nebula to Earth at 700 light years, and supernova remnants such as the Crab Nebula in Taurus. Some nebulae can be viewed with the naked eye, such as M42, the Great Orion Nebula, but some are very faint and difficult to see, and these are the ones that nebula filters are made for. Stars emit light across a broad spectrum of colors, but nebulae emit light at very narrow wavelengths, mostly from ionized hydrogen atoms, which emit at 656 nanometers, which is red, 486 nanometers, which is blue-green, and ionized oxygen atoms that emit at 496 and 501 nanometers in the green wavelength. Narrowband filters allow only a narrow band of spectral lines from the spectrum of light, which goes all the way from ultraviolet to infrared. Humans can only see light on the spectrum from about 300 nanometers to 700 nanometers. I think Del Woods of Daystar invented nebula filters in the 70s, but they were popularized when they were introduced widely by Lumicon in the early 1980s. There are 4 different types of nebula filters. There are light pollution filters that allow in a broad spectrum of light and are intended for lightly light-polluted areas. They work well to increase contrast for galaxies, but not so well for nebulae, and they cannot block light from LED lights. Astronomics sells the CLS light pollution filter, and there's also the Lumicon Deep Sky filter. I don't own a light pollution filter, and I've never used one on a telescope. Personally, I'm willing to take the time to drive out to a dark sky site because I'm retired and I have lots of time and I have time to do so, and it gives me great pleasure, and because I find light polluted sky depressing. Next, there are ultra-high contrast or UHC filters. This filter offered by Orion is the Ultra Block, and there's also the Optilong UHC, Astronomic, and Lumicon UHC. The UHC filter is the one you would use the most, and it's the one you should get before getting any other nebula filter. They allow in light from 482 to 506 nanometers, and they significantly improve contrast on emission nebulae such as NGC 7000, the Lagoon Nebula, and the Veil Nebula in Cygnus. Then there are O3 filters. They let in light from 496 and 501 nanometers of doubly ionized oxygen, which is blue-green. They're great for planetary nebula and supernova remnants. But I use them on everything because I bought an O3 filter before I bought a UHC filter. Now I'm sold on the UHC filter, and I highly recommend that. If you can get only one filter, start with a UHC filter and then get the O3 filter to add to your arsenal, because they'll enhance different parts of different nebulae, which I'll be demonstrating later. O3 filters can be bought from Orion, Lumicon, Astronomic, Astromania, Teleview, and Celestron. You might find that if you're using a large aperture telescope with a long focal ratio, that the O3 filter darkens the sky too much and makes it hard to see anything. But I've found that it really depends on what you're looking at. Then lastly, the narrowest of the narrowband filters is the H-beta filter. They only allow in light around 486 nanometers, the blue-green beta emission line. They're limited to a few objects, most notably the Horsehead Nebula in Orion and the California Nebula, and a few others. Now that I've told you about how nebula filters work and what they do, let's go out into the field and try these filters out on some nebulae and see what kinds of results we get with the different filters. I don't own a light pollution filter, like I said, so I won't be testing one of those in this presentation. I will be testing a UHC, an O3, and an H-beta filter of various brands. Before we go outside to test out some of these filters on nebulae, I wanted to tell you a couple of things. Number one, make sure you buy filters for a telescope and not photographic filters. All of mine are 1 1/4 inch because all my eyepieces are 1 1/4. And the way you put them in is you just screw them into the end of your eyepiece like this. Now let's go outside. I'm out here in a reasonably dark place in Northern California for some stargazing. It's a beautiful evening for stargazing, and I have my 8-inch Meade-Schmidt Cassegrain for visual observing. And on this mount, I have my 80mm refractor, and I'm going to be testing out some narrowband filters for telescopes. I've got an Orion Ultra Block filter. It's what Orion calls their UHC filter, ultra high contrast. I have an O3 filter, which allows 2 lines of the doubly ionized oxygen. And I have a Lumicon H-beta filter that I don't think there's anything I can use it on, but I'm going to be comparing these filters on both of these telescopes to see how they do. Okay, I have IC 5146, the Cocoon Nebula, in this 80mm refractor. With the eyepiece, I can't see anything. So I'm going to try this UHC filter that Orion calls Ultra Block and see if I can see anything. But I don't think I will, because I think you need a bigger aperture telescope for that particular nebula. I still can't see it, even without this light on. So now I'm going to put this filter in the 8-inch telescope. I think you need at least an 8-inch telescope to see IC 5146. I could see a hint of the nebulosity in this telescope with just the eyepiece. Now I'll see what happens when I put in the UHC filter. I'm going to turn off this light and find my red light. I also gave my eyes a chance to recover from that light. Okay, I have the UHC filter in this eyepiece, and this is my 8-inch, and it's on IC 5146. And now I can see the nebulosity. pretty neat. When I put the UHC filter in this 80mm telescope, I wouldn't say it looked like North America, but it had a definite shape with a curve in it. And I experimented with just for fun, I put the O3 filter in, and then I even put the H beta in just to see what it would do. It just limited it to a small curve at the top, but definitely a UHC filter and a small telescope brings out the nebulosity of NGC 7000. Hello again. I'm out here in a Bortle 3 in Northern California. I think it's SQM 21.10, something like that. So reasonably dark. And I have my 8-inch Schmidt-Cassegrain, because you want big aperture usually to look at nebulae. But I also have my 80mm refractor over there because some of these nebulae are so big that you need the lowest magnification possible to fit them in the field of view. And it's hard to get that low of a magnification on a Schmidt-Cassegrain because of the long focal length. But on the 80mm refractor, it's perfect for some of the large nebulae like NGC 7000. Also have an astronomic UHC filter. And I haven't tried this one yet, I just got it. I'm going to be comparing it with the Ultra Block, which I think the Ultra Block I'm very impressed with. I like it a lot. It works very well. But I'm going to be comparing these filters to see how they do on various nebulae. The transparency is bad. It's been smoky in Northern California the past few days, and the air is unhealthy. Frankly, I shouldn't be out here. It's been so bad, but in addition, it's windy. That's why I have on so many clothes. The wind is making it feel much colder. Okay, I have the astronomic UHC filter in with a 36mm eyepiece. And I can see more of the nebulosity. That helped a lot. Now I'm going to turn this red light off because I want to see it as clearly as possible so I can compare the Ultra Block filter from Orion with the astronomic UHC filter and see if I can detect any differences between those two filters. I've been gone a long time. I was looking at things with the 8-inch telescope so my eyes could get dark adapted before I looked again, so I could get a better idea. I looked with the astronomic UHC filter and it looked pretty good, but I have to say it looked even better with the Ultra Block from Orion. That's a very good filter, so I could see even more. Okay, I have the Lumicon H beta filter in here, and I can just see a semicircle at the top. It really blocks out everything else. It's too dark. I really bought it for the horse head because I'm going to try again for the horse head this winter. But for NGC 7000, I think the best filter is the UHC filter. Now we're going to look at NGC 7293, the Helix Nebula in Aquarius. I couldn't see it in the 80mm refractor, and it's difficult to see because of low surface brightness. But now I'm going to have a look with the 8-inch telescope and see if I can see it. I couldn't see anything. I tried everything. I tried the O3, I tried the UHC, I tried the astronomic UHC, I tried the H beta. I couldn't see it, and I have seen it before from a Bortle 3. Maybe because the transparency is not very good tonight is why I couldn't see it. And I'm pretty sure when I saw it before I used an O3 filter, but I can't replicate that result. So let's go to something else that I know does respond very well to filters, and that is NGC 6960, part of the Veil Nebula. It's a supernova remnant. but it responds very well to a UHC filter. So I have it in my telescope now. I normally I can see it without a filter, but tonight I couldn't see it, or just not very well. But I now put the filter in, and it looks really good. It has this big arc right by 52 Cygni, and that shows very well with the O3 filter as well. I still have it on the Veil Nebula, and I put the Orion Ultra Block on it, and I could see the nebula more clearly with the Ultra Block. However, 52 Cygni was blue with that filter, and when I took it out and put in the astronomic UHC filter, 52 Cygni was kind of orangey, but the nebula was not quite as distinct as the Orion Ultra Block. So if you can overlook the blue star, I still think that Orion Ultra Block performs a little bit better than the astronomic. There's nothing wrong with the astronomic. It's a good filter, and you should get a UHC filter to enhance your view of nebulae. But I just feel in this comparison, which is kind of hard, but I think I like that Orion Ultra Block better. But frankly, the Veil Nebula responds to almost any filter. It just pops. Okay, let's go to something else. The conditions are very bad, and it's not good. Things are getting on my filters, and I took an SQM, and it was not even 21. It was 20.87. And I looked at the Milky Way, and I can barely see it, which normally I can see the Milky Way very well out here. And so I'm going to have to resume this at a later date with better conditions, because to see nebulae, you want good transparency. It's key. You got to go to a dark sky site, you need good transparency, and you need filters. So I'll be back soon with more about filters. Hello again. I left Los Baños. It's normally an excellent place for stargazing, so close to the Bay Area. According to Zasteria, it's a Bortle 3, but I took an SQM and it wasn't even at 20, which is terrible. And there was a lot of dust and smoke in the air, and it was windy, and I left there, and now I'm in Dark Skies, Montana, and I took an SQM here, and it's 21.37, which is pretty good. So I first put my telescope Artemis on NGC 7000, and I could see it without even a filter. It doesn't all fit in here, even with a 36 millimeter eyepiece, because that's 100 times magnification, and you want low magnification to fit it. But I could see part of it. I think it was Mexico, I'm not sure. But I then put this UHC filter that I have here, which is a cheap UHC that I bought from Astromania, but it really brought it out. So that was pretty good. But dark skies are very important to seeing some of these faint nebulae. Next, I went back to the Helix Nebula, NGC 7293, because I was mad I couldn't see it. So I got it in the telescope, and I could see it without even putting a filter on. And it's another pretty large nebula. And then I put the UHC filter on, and it really brought it out. So I don't know how well it will do on everything, but so far this little UHC filter from Astromania has done very well. I've been gone a very long time. It was hard for me to peel my eyes away from the Helix Nebula. It's so pretty. I like it even better than the Dumbbell Nebula. So if you haven't seen it, go to a dark sky site and check out NGC 7293, the Helix Nebula in Aquarius, and take your UHC filter with you. Now I'm on a very difficult object, NGC 1499, the California Nebula in Perseus. It's a very difficult nebula. I think I can see a hint of nebulosity without any filter, but now I'm going to start with UHC, but I think I may need an O3 filter, but I'll see how the UHC filter does first. I'm using a 36 millimeter eyepiece, so that's 100 times magnification. That's as low as I can get. So I can't fit the whole thing, but I can see the San Francisco Bay Area. Just kidding. Greatest place on earth. But it just looks like a semicircle. Then I put the UHC filter in, and it helped a lot. I put the O3 filter, and it helped somewhat. And I put the H beta in, and it just makes sections of it more apparent, but other sections no. So I think I'm going to look again, but I think I'm going to say I could see it best with the UHC filter, but I'm going to try to sketch it, how it looks with each filter, and I'll show you those, but I have to go to bed. I didn't go to bed, like I said. It's so late that Orion came up, so I was trying to see the Horsehead Nebula. I couldn't see the Horsehead Nebula. Orion was too low. So I'll wait till winter time and try again. And also I didn't let my eyes get dark adapted enough. But I'm really impressed with this UHC filter I bought from Astromania. It was very cheap. I think it was $30. And a lot of them are expensive. So that's it for nebula filters. I hope you enjoyed it. I'll see you soon. Until then, get outside and enjoy the night sky. Dark skies forever. Sula signing off.